Hi, good morning. This is Divya. In previous video, we have discussed about the digital sensor interfacing, how the sensors to be interfaced with the microcontroller. Now we are going to see the application that uses sensor data for decision making under the unit microcontroller and interfacing techniques for IoT devices. These are the components that are required for making for decision making applications of decision making. We have different applications in IoT. Using sensor data for decision making with Arduino can be applied in numerous applications across various domains, from environmental monitoring to home automation and robotics. These are the examples that we are going to see. Some examples are smart home automations, environmental monitoring, industrial automation, robotics and navigation. In smart home automation, temperature and humidity sensors are used. Arduino can use data from DH11 to DH11 or DH12 sensors to monitor the indoor climate conditions. Based on the predefined thresholds, the Arduino can activate or deactivate heating, ventilation, or air conditioning systems to maintain a comfortable environment. Next one is a motion sensor. Motion sensors like PIR sensor can detect movement in a room. Arduino can use this data to control the lighting, security alarms, or even notify homeowners of potential intruders. In environmental monitoring, next example is an environmental monitoring. Air quality sensor. Sensors like MQ series can measure various gas concentrations in the air. Arduino can analyze this data and activate air purifiers or send alerts to the concerned persons. And next, also in environmental monitoring, soil moisture sensors are also used. In agriculture, soil moisture sensors can provide data on soil hydration level. Arduino can use this information to automate irrigation systems, ensuring plants receive whether it receive the adequate water. Next application is an industrial automation. In our industrial automation, proximity sensors and pressure sensors are used. Proximity proximity sensor, inductive or capacitive proximity can detect sensors can detect the presence or absence of an object on a production line. Arduino can use this data to control conveyor belts, sorting mechanisms, or alert operators of potential issues. In pressure sensors, we can monitor fluid level in tanks or pipes. Arduino can analyze this data to control pumps, valves, or send alerts. In our next application is robotic and navigation. Here, ultrasonic sensors are used to measure the distance of an object. Arduino can use this data to avoid the obstacles that are present. And also in our autonomous vehicles, we are using ultrasonic sensors. Now we are going to see the temperature sensors. We are going to use an Arduino board and temperature sensor, fan or relay model to control a fan, breadboard and jumper wires. These are the steps to create this application. Connect the temperature sensor and fan to the Arduino board and read the sensor data. Based on that, we have to write the code to read the temperature from sensor. And decision logic, we have to implement an algorithm to make a decision. And actuation will control the actuators or fan or based on the decisions made. This is the program for a temperature sensor. Here we have initialized the DHT sensors, and we have made pin connected to the digital pin connected to DHT sensors, and we have made the 13th pin connected to the digital pin, and we have created a threshold temperature of 25 degrees Celsius, and we have made LED pin as output. That means 13th pin as output, and we have to start the program. Next one is we have to read the temperature from the sensor. Based on the temperature value, we have to make the decisions. Yeah, well, it will check the threshold value. If it is greater than the threshold value, it should turn on the fan or actuators. If it is less than the threshold value, it should switch off the fan or actuators. This is the program for controlling the temperature sensors. And decision making are based on the temperature. in this program, and the temperature greater than temperature threshold temperature, we have to turn on LED, and temperature above threshold is we have to switch on LED, or we have to switch on the fan or actuators or air conditioners. If the temperature is less than the threshold value, we should switch off the fan or LED or air conditioners. Thank you.